computer. All right, so today we are going to be reviewing most of what we've done with linear equations, all right? When it comes to forming linear equations and solving it from word problems, when it comes to figuring out if it has one solution, many solutions, or infinitely, what did I say? One solution, no solution, or infinitely many solutions, or just even figuring out how to solve equations with x's on both sides. So to start out, we're going to look at, let me get my text box right here, solving equation with the variable on both sides. That's what we're going to start with. All right. And go ahead and put your answers in the chat as I write it down. So we're going to start with negative 2x plus 7 is equal to negative 4x minus 6. So as we always work these problems, our goal is to try and get all the x's on one side and everything else on the other side, all right? Or all the variables, the like variables on one side and everything else on the other side. It's combining like terms, but across the equal sign. But when we're doing that, we always have to remember that we have to do the additive and the multiplicative inverse to get things across, all right? So my first thing, I'm gonna move this negative 4x to the left side. I like moving my stuff to the left. It's just a preference. You can move your stuff to the right. So I'm gonna do plus 4x. Whoopsies. And whatever you do on one side, you gotta do it to the other side. All right, so then this becomes 0 right here. This becomes 0. And then I have to solve this part right here. So it's 4x minus 2x, which is 2x is equal to, oh, eraser pen. 2x plus 7 is equal to negative 6. All right, so then now I have to move the 7 to the other side, and it's a plus 7, so I have to do minus 7. Right, so then now this right here is 0. 7 minus 7 is 0. There's a minus right there. Similarly, we have to solve this part, which is equal to negative 13. So 2x is equal to negative 13. So now I have to divide both sides by 2. So x is equal to negative 13 over 2. And you can leave your answers like that. You don't have to necessarily solve out the decimal point or anything like that. All right, we're going to leave it at that. Again, you could always go back and watch this video. The next thing we're going to look at is figuring out if if an equation has one solution, no solution, or infinitely many solutions. So I want you guys to put in the chat, and as I put this in, so one solution, no solution, or infinitely many solutions. All right, so the first question we're going to look at, and just to review what the criteria are. So if I have x equal to a, I know that's one solution, a being a real number. If they're both equal to each other, so for example, a equals a, right? Many solution. And we'll see what a is soon. Or if a is equal to b, and we know that's not true, then it's no solution. For example, if I have x equals 7, this one right here, if I have 7 equals 7, And this one right here, 5, 7 equals 8. And we know this is not true because 7 does not equal to 8. Right? So to give an example, we're going to do 2x, I'm going to negative 2 plus 4 is equal to minus 2x minus 8. So now let's solve this. All right, we have to do the distributive property because we have some parentheses in there. So this is minus 2x minus 8 equals negative 2x. We could already look at this and tell what it is. Can you see what it is already? We could already look at this and tell if it's one solution, many solution, or no solution. Go ahead and put it in the chat. We have negative 2x minus 8 equals negative 2x minus 8. We could already look at this and tell what it is. All right, we don't have to necessarily solve it all the way down. I'm getting one solution. Let's look at it. This side is equal to this side. Infinitely many. So remember with infinitely many, A is equal to A. And I gave the example 7 equals 7. And we already say that this whole thing right here, they're both the exact same thing. Do you see that? This and this, they're the same thing. So that's why it's many solutions. We could continue working it out. And if we continue working it out, we're going to end up with negative 8 is equal to negative 8, which is basically what A equals A is, telling us that it's many solutions. All right. So that's how I'm only going to work this one problem, but that's how you go through and you solve. And I put these examples right here so that you could start getting familiar with just general terms when I say x equals a. So if I worked it out and I said x equals negative 8, then it would have been one solution. If I worked it out and I ended up with negative 8 equals 10, there would have been no solution. All right. The next question we're going to come up with an equation from a word problem. Forming equations from word problems. And let's get one together. Let's change the color. There, I'm going to say Jana is renting a book from Amazon, and the daily cost is $3 plus an added fee of $15. At the end of her time needing the book, she spent $48. How many months how many days did she borrow the book for? So remember, whatever they're asking us to find is what our variable would be, all right? So right here, they're asking us to find how many days. So let me go ahead, right there. That's gonna be my variable. So I'm gonna put my X. X is finding how many days did she borrow it, right? Wait, this is not working out. Okay, there it is. How many days did she borrow it? So I'm put X. And then now it said it was $3 per day. So I'm gonna put 3 here. Actually, let me just do different colors so it's like more understandable. So this 3 right here is gonna end up going here. All right. And then they said that there was an added $15. No matter what, you still have to pay $15. So this right here, and it's added. So it becomes plus 15 And that is equal to, it said that she spent $48 overall. Wow, right here, $48. So that's how I write my equation. And then I have to go through and solve it. And you solve it just like how you would regularly. So this is minus 15, minus 15. So 3x is equal to 33? And then I have to divide right? So x is equal to 11. So she borrowed the book for 11 days. That's what that is saying. So then in my final statement, I would say she borrowed the book for 11 days. There it is. Bam. So that, I just wanted to go over 3 questions real fast just to see and show that this is how we approach these. We've been doing this for a couple of weeks now. If you have questions, feel free to reach out to me through email or anything like that. All right.